Today, we are cracking the code on one of the most fundamental ideas in data, correlation. Now, this is the tool that helps us find hidden patterns all around us, but you know what? It also hides one of the biggest, most common traps in all of statistics. So let's dive right in.
Here's what we've got lined up. We're going to start with a pretty surprising illusion that trips up even the experts. Then, we'll decode what correlation is actually measuring, check out the tools we use to find it, and cover the one golden rule you absolutely, positively cannot forget. And finally, we'll see how you take this thing from just a clue to a real, solid conclusion.
Okay, let's kick things off with a statistical fact that seems, well, completely bizarre, but it perfectly sets the stage for everything we're about to cover.
I know, this sounds absolutely ridiculous, right? But what if I told you that the data, the actual numbers, show a connection?
And get this, it's statistically true. The data shows that as the number of films Nicolas Cage appears in goes up, so does the number of pool drownings. If you were to graph these two things, the lines would move together in a way that looks, well, incredibly similar. It's a real correlation. So, what in the world is going on here?
Well, what you're looking at is a perfect example of what's called a spurious correlation. It looks real on the surface, but it's totally meaningless. And learning to tell the difference, to spot these illusions, is one of the most critical skills you can have when you're looking at data. Let's break down how to do it.
So to steer clear of that trap, we've got to get really clear on what correlation actually is, beyond those misleading headlines and weird examples.
So here it is, the official definition. At its core, correlation is simply a statistical measure of how two variables, move in relation to each other. That's it. It's just a number that describes a relationship. Now, the key word there is describes. It doesn't explain the relationship. It just puts a number on it.
And to really understand that relationship, we're basically looking at three key things: the direction they're moving in, the strength of that movement, and whether or not they move together in a pretty straight line.
Direction is really our first clue. Are these two things rising and falling at the same time? That's positive. Or does one go up when the other goes down? That's negative. Or, is there just no real pattern at all? Just random noise?
Let me give you two super simple examples. For a positive correlation, think about this. The more time you spend studying, the higher your exam score tends to be. They go up together. For negative, think about a car. As its age increases, its resale value goes down. They move in opposite directions. See? Pretty straightforward.
Okay, so now we know what it is, but how do we actually measure it? How do we put a number on that relationship? Well, that's where our toolkit comes in.
Now, you might have heard of another term, covariance. It's a related idea, but what makes correlation so incredibly useful is that it's standardized. It takes any kind of messy raw data from any source and puts it on this one simple universal scale, from -1 to +1. And because of that, it's super easy to interpret and compare, no matter what two things you're looking at.
And this little table here, this is basically your cheat sheet. The closer that correlation value gets to +1, the stronger the positive relationship. The closer it gets to -1, the stronger the -1. And if that number's just kind of hovering around 0, well, that's a pretty good sign that there's no real straight line connection there at all.
And just a quick pro tip, it's not a one-size-fits-all deal. The most common tool is called Pearson, and that's great for those clean, straight-line relationships. But what if your data is ranked, like good, better, best, or the relationship isn't a straight line? Then you'd use something different like Spearman or Kendall. It's all about picking the right tool for the job.
All right, everybody, lean in for this next part. This brings us to the single most important, crucial, can't-miss takeaway of this entire explainer. Seriously, if you remember only one thing from our time together, please make it this. Just look at these examples. Ice cream sales are strongly correlated with shark attacks. Does eating ice cream make sharks attack people? Of course not. People with higher salaries tend to drink more coffee. Does drinking more coffee magically make you richer? Probably not. These correlations are statistically real, but the conclusion you might jump to is completely false.
So here it is, the golden rule. This is the mantra you need to repeat to yourself every time you see a chart or read a headline. Correlation does not imply causation. Just because two things happen to move together does not ever mean that one is causing the other.
So you're probably asking, why does this happen? Well, sometimes it's just pure random chance. But way more often, there's a third, hidden factor at play. With the ice cream and sharks, what's the hidden variable? Summer heat. Hot weather makes more people swim and makes more people eat ice cream. The two aren't causing each other. They're both being caused by something else entirely.
Okay, so if correlation isn't the smoking gun, if it's not causation, then what good is it? Is it just some kind of statistical party trick to fool people with? No, not at all. I want you to think of it this way. A strong correlation isn't the answer. It's a giant flashing signpost on the side of the road that's screaming, "Hey, look over here. Something interesting might be going on. You should definitely investigate." It is the start of the journey, never the destination.
And you see this in action all over the real world. In finance, investors look for assets with low correlation to spread out their risk. In marketing, you track if your ad spending correlates with more sales. And in healthcare, that initial, powerful link found between smoking and cancer, it started as a correlation that launched decades of life-saving research. It is an absolutely essential first step.
And in today's world of machine learning and AI, it's completely indispensable. Data scientists rely on it to pick the most important features to build a model, to help clean up messy data, and to make sure they're not feeding redundant information into their algorithms. It really helps make our models smarter and a whole lot more efficient.
So let's wrap this all up. What does correlation tell us? It's fantastic for showing the direction and strength of a relationship, and it's great at pointing us toward variables that might be good predictors. What does it not tell us? It never ever tells us why that relationship exists. That's a different question that requires a whole lot more work to answer.
And that, ultimately, is the best way to think about it. Correlation isn't just a number on a spreadsheet. It's a gateway. It's the key that unlocks the door, inviting you to look deeper and begin the real work of transforming raw, messy data into genuine understanding.